the momentum of a body, you know what is the momentum of a body? Momentum of a body is denoted by P, right? If P is the momentum, if P is the momentum, then momentum is the product of M and V, right? Where M is the mass and V is the velocity. This is mass and this is velocity, right? M, the product of mass and velocity will give you the momentum, right? Now, just the question is that if the momentum of a body decreases by 10%, so P decreases by 10%, right? That means we can say that if the mass of the, we can say that P product of mass and velocity is momentum, right? Product of mass and velocity is momentum. Then P decreases by 10%. We know by the formula we can see that if momentum is product of mass and velocity, we can see that momentum is directly proportional to mass and momentum is directly proportional to velocity, right? Now the question is that the momentum decreases by 10%. If this momentum is decreased by 10%, then percentage decrease in kinetic energy. Then percentage decrease in kinetic energy is what, right? That we need to calculate. Now, we know that since the momentum decreased by 10%, the mass will be constant, right? Mass will be constant. But because this is applied on the same body, if this is the mass, if this mass is M, then in the initial condition, the momentum carries the same mass, and in the final condition, which is the second condition given, the mass will be constant. So what will be actually varying? Variation is basically into this velocity, right? So if P decreases by, if P decreases by 10%, if P is 10% less, then since P is proportional to velocity, then velocity of that particular body is also decreases by 10%, isn't it? This is also decreases by 10%, right? So with this condition, let's say if this is the initial condition and this is the final condition, that means the second stage, right? If here P and M and V, right? Then here in place of V, half Pascal, in place of V, the new velocity will be 10% less. So this minus 10% less, that means 9 by 10. So this is the only velocity which is remain. This is the final velocity. That means the second stage. In the second stage, this will be the velocity. 9 by 10 times the velocity, right? Now, it's asking that percentage decrease in kinetic energy. Yeah, Pascal, you can say me what's your query. So we know the formula of kinetic energy is half into mass into velocity square, isn't it? I think every one of us is knowing it, right? If kinetic energy is half into m into v square, Then percentage decrease. So percentage decrease or increase in any value is equal to delta by the initial value into 100%, right? So what is delta over here? Delta is the change in kinetic energy. So because we are calculating the percentage decrease in kinetic energy, this will be the final initial minus final, that means the change. Delta is the change. So we can say initially it was half mv square, now it is half into m into 9 by 10 times 9 by 10 times v square, right? This will be the change in the velocity, kinetic energy, sorry, change in kinetic energy divided by the initial value of the kinetic energy. What's that? Initial value was half mv square into 100%. So just multiplied it by 100%, this complete bracket, right? Now like this, okay. Now what I will do, mva square, mva square, mva square, all will be cancelled out, and we are left with 1 by 2 minus, and even 1 by 2 can be cancelled out. You can see 1 by 2 is in all the three terms. So we are left with what? This is 1, the first term, minus 9 by 10 whole square, right, divided by 1 into 100%, right? So this will give you 1 minus 81 by 100 into 100%. So 100 minus 81 is 9. So this will give you 100 minus 81 is 19. 19 by 100 into 100%, right? So this will give you 19%. 19%. So we can see 19% is the decrease in kinetic energy which we observe when the momentum decreases by 10%. So students, if you think you like this solution, you just like and subscribe. For any query, you can put up into the comment box. Okay. Yeah, Pascal, now we can come to your query. Let me know what's your query, babe. What's your query? Please. I hope you understood this solution. Here, the momentum decreases by 10%. We need to find the percentage decrease in kinetic energy. Since momentum is directly proportional to velocity and mass, but mass is constant, right? So that's why velocity is directly proportional to momentum. Here P is the momentum. Since P decreases by 10%, then V also decreases by 10%, right? If V decreases by 10%, the new velocity will be 9 by 10 times the initial velocity, right? Now, what is the percent? We know the formula of kinetic energy, it's half mv square. Where did the P and M go on the final side? Jaffer. Hi Jaffer, good morning. So P and M will never go anywhere, Jaffer. Actually, this is the percentage decrease in kinetic energy which we need to calculate, right? So the percentage decrease, we know the formula of a percentage decrease of any quantity, any physical quantity. This is the delta by the initial value into 100%, right? So here you can see mva square, half mva square here, half mva square here, all will be taken common and it will be cancelled out, right? So delta, so it's not nothing that P and M will go on any side, right? So the percentage decrease will be the change in the kinetic energy. Initial kinetic energy was half mv square. Now the final kinetic energy with velocity of 9 by 10 v will be half into m into 9 by 10 v whole square, because this is the new velocity 9 by 10 v. You can see it here, right? This will be the change divided by the initial, that is half MBA square. So half MBA square, half MBA square, half MBA square taken common in across all the three terms, and we are left with 1 minus 9 by 10 whole square by 1 into 100%. So this is the percentage decrease in kinetic energy. When we solve it, you will be having 1 minus 81 by 100, this one into 100%, and this will give you, when you solve it, 19 by 100 into 100%, which will give you the final value of 19%. So the percentage change in kinetic energy is 19%. When is 19%? That means when the momentum decreases by 10%, this will give you a 19% decrease in the kinetic energy, right? Okay, thank you. Not like the board mass I am used, but happy to learn. Thank you, Jafar. Thanks. Just if you like it, just like and subscribe. And yeah, this is no board mass over here. This is a simple physics. It's a numerical. Okay, so I don't think we need to apply board mass over here. Okay, here you can see half MBA square in all the three terms. We have taken common and deducted it. Okay, it cancelled out, and we are left with 1 minus 9 by 10 whole square by 1, and this is simple arithmetic calculation. Finally we get 19%, right? I hope you like it. Thanks for watching, Jafar. I will come with next sessions with live sessions, okay, and I will explain these numericals over here. Okay, just like and subscribe, you find it useful. Thank you so much, students. Take care. Bye bye.